In this video, we're going to determine the compressive strength of a moulded concrete cylinder. This is commonly called a strength test. The relevant standard is NZS 3112, Part 2, and determining the compressive strength of a moulded concrete cylinder is described in Section 6. You should note that the standard specifies in detail in Section 3 how cylinders should be prepared and stored during the curing period. For more information on preparing and curing test cylinders, see the CCAN cylinder preparation video. To conduct a strength test, you'll need the following equipment: a set of weigh scales, a steel square, a gap tolerance foil, a damp and a dry cloth. You'll also need to record the results of the test in your company's quality control system and wear waterproof gloves when collecting cylinders stored in water baths. The standard outlines a number of ways to prepare the cylinder for testing. In this laboratory, the use of a grinding machine is routine and ensures the ends of the cylinders are flat and smooth. Retrieve the cylinder from storage. Note that concrete containing water baths are extremely alkaline and that hand and eye protection should be used. Also note, the standard states that the cylinders should be stored in the lab at a temperature of 21 degrees Celsius plus or minus 2 degrees Celsius. The first thing to note before doing anything else is to look at the general condition of the cylinders. We're particularly looking to see large voids and obvious defects in the cylinder. A test performed on a grossly defective cylinder will not be representative of the concrete strength. As you can see here, the cylinder clearly does not have a smooth top and is not perpendicular to the side. On this cylinder, the top is not smooth and has been cured with a large unacceptable void. Also, look for voids on the walls of the cylinder. These should not be more than about 5 mm in diameter. A good rule of thumb is, if you can fit the rubber end of a pencil inside them, they're too big. Voids like this are formed due to incorrect cylinder preparation. The voids occur when cylinders are not rodded correctly to expel the entrapped air from the fresh concrete. Dry off the excess water with a dry towel and ensure that they don't dry out by keeping them covered with a damp cloth when not in use. The cylinders must be tested in the saturated surface dry condition, commonly referred to as SSD. If using a grinding machine, refer to your company's instructions on its correct use. While a grinding machine ensures that test cylinder faces are smooth, it is not required by the standard. Other methods include capping with a sulfur mortar or rubber. Regardless, the standard requires that the cylinder ends are smooth, not concave or convex, and that they are square or perpendicular to the cylinder edge. Check the plainness and perpendicularity of the cylinder using a right angle and tolerance gauge as shown here. The standard states that the ends cannot deviate from perpendicularity by more than 0.5 degrees, which is around 1 mm in 100 mm. They can't be convex or concave by more than 0.05 mm. They can't contain a projection from the surface greater than 0.05 mm, and the end should be no more than 1.5 degrees from the horizontal, which is 3 mm over 100 mm. As mentioned, slight perturbations in the above can be corrected by either grinding or capping the cylinder end. The standard specifies how and what capping materials are acceptable for use in Section 4. Check the edges of the cylinder and note any defects. The diameter of the cylinder is measured twice near the midpoint to the nearest 0.1 mm, with each measurement approximately at right angles to the other. The two measurements must be within 2% of each other. The height of the cylinder is also measured to the nearest 0.5 mm. The ratio of the height to the diameter must be between 1.9 and 2.1. Note that achieving the required accuracy of the diameter and height measurements is very difficult using a ruler, and most labs have a specialised piece of equipment to make these two measurements routine, as is shown here. Note that these measurements are required by the standard and hence should be recorded permanently. Also note that while not needed for the strength test, the weight of the cylinder is often recorded at this point, as it will indicate the density of the cured cylinder. If you're not using a grinding machine to ensure a smooth end, rubber caps, as shown, can be used on the upper end during the test. Place the cylinder in the centre of the test machine. A cylinder off-centre will crush at a lower pressure than the one correctly centred. Ensure the correct health and safety procedures are followed. While most modern strength testing machines will have a fail-safe protective door, such as this one, older machines may not. When cylinders fail, they may explode fragments into the laboratory area, causing injury. Increase the load on the cylinder at a rate of 10 to 20 megapascals per minute. Generally, aim for 15 megapascals per minute. Record the maximum load applied in kilonewtons, which is then used to calculate the cylinder strength. The megapascal strength is the load in newtons per square millimetre of the cylinder end. Record the strength to the nearest 0.5 megapascals, along with any defects noted during the initial inspection. CCANS would like to thank the crew at Wholesome Bombay for their time and the use of their facilities.